Hi, and welcome to Objective 2, Chapter 27, where we're going to take a look at some of the basic tools of finance and use and present the time value of money. So let me go ahead and share my screen with you. I think this is the one. Okay. Oh, help if I start the slideshow. So let's see from beginning. There we go. Okay, so we're going to work through a problem. And essentially, the time value of money, you also encounter this in Principles of Accounting too. So you might be a little familiar with it if you've had that course. So there are two ways to look at the time value of money. Each are a reciprocal of each other. There's the future value, and the future value is equal to whatever the present value is times the future value interest factor for a certain time period. We'll call that N, for a certain interest rate, which we will call R. Okay, so it used to be back in the day, you had to look these up in tables and so on. But in the intro to this, I did give you a calculator that you can use. We're just doing some simple compounding here. So what is compounding? Well, you probably have learned how to calculate the interest rate. And we would say that the interest rate, or in this case, R, is equal to, I should say or, R, is equal to principal, whatever you're starting with, times the rate, times the time period. Probably learned that in grade school, okay? And that works out okay if you're only doing a couple periods, but basically what we would like to do is to add this interest in and figure out a quick way to say do 20 time periods, okay? So you put $100 in a bank account, how much will it be worth in, say, 30 years? Well, we could use the principal times rate times time problem and do that for year one. Add the interest in, so principal plus interest, and then times rate times time for year two. Keep doing that and doing that and doing that. Very cumbersome, okay? So we've come up with a really quick way to get to the future value. And again, you'll notice that here, instead of using the formula is really the future value is equal to the present value. In this case, it would be 100 times the future value interest factor for, let's see, whatever we're earning. So like say 8% is our rate of interest here. So for 8%, and we would do it for 30 years. Now we don't have the factor tables anymore, so there's an easier way to do it. We can say the future value is equal to the present value times 1 plus the interest rate to a given time period. Okay, so again, if we're using this problem, so our present value is 100, so the future value is equal to 100 times 1 plus the interest rate, 0.08, and then we're going to take that to the 30th power, okay? So essentially we have the future value is equal to 100, 1 plus 0.08 to the 30th power, and I'll get my handy dandy calculator here, 1.08, oops. Oh, how about 10? So our factor that we're going to take it by is 10.062 times 100. So go ahead and multiply that out, and we end up with 1,026. And that would be our future value. How much would you have to deposit in a bank right now to yield $200 in N years? And again, there what we're going to do is calculate what the present value is. So we use the present value divided by 1 plus the interest rate to the nth power. So again, the present value is going to say the future value divided by 1 plus the interest rate to the nth power. Or what we can say is the present value is equal to the future value times 1 plus the interest rate to the negative nth. It's doing the same thing. So this is the reciprocal, if you will, of the present value. It's what we call, the reciprocal of the future value. And so again, here's what we're going to be using is this formula here, or what we can use is, again, the future value times 1 plus the interest rate to the negative nth power, and that's an n. There we go. Okay, so that equals the present value. So let's take a look at what might be some examples of when we would use this. You're thinking about buying a 6-acre lot for $70,000. The lot will be worth $100,000 in 5 years. First question, should you buy it at an interest rate of 5%? Should you buy it at an interest rate of 10%? So there's two ways you could really do this. There's one that's more appropriate than the others. So let's take a look at the problem. So right now, our present value is $70,000. Our future value is 100,000. The N, or the time periods here, is 5. The interest rate, or the rate of return, is 5%. So let's go ahead and do A first. And so I'm going to go ahead and advance the slide so I've got some workspace. And so at 5%. So again, our present value, our future value, and N equals 5. Interest rate is 5%. Now, again, as I said, you could do this two ways. You could propel it into the future or bring it to the present. It is always more appropriate to bring everything back to the present if you have that option. So here, what we're going to do is use the present value of 70,000 as kind of a mark, okay, a barometer, a test, okay? And what we're going to do is we're going to compute what is the present value of the future value times 1 plus the interest rate to the negative nth. So our future value here is 100,000. Our interest rate, or R, is 0.05. And we're going to take that to the negative 5th power. And when I do that, I'm just going to grab my calculator here and do that. Let's see, 1.05, 5 plus minus. Okay, so we end up with a compounding factor of 0.7835. Okay, and we're going to multiply that by our 100,000. And we end up with the present value is equal to 78,352.60, and I'll just round it to 2. Okay, so here's the question. Which would you rather have, 70,000 or 78,000? I'd much rather have 78,000, and because I'd rather have the present value I calculated, I would totally buy the lot at 5%. Okay. Now, whoops. Okay. Should you buy it at 10%? So I'm going to go ahead and erase the slide. I just want to keep the 78,325. So let me go ahead and write. So the answer here was 78,352. 352.62. 352.62. So that was a yes. Okay, so let's do B now. Should you buy it at 10%? So again, we're going to compute. We're going to use 70,000 as our kind of check figure over here. And we're going to say that the present value is equal to the future value. I'll show you this one a little differently. Over 1 plus the interest rate to the nth power. So now I'm just dividing. So our future value, 100,000. Our present value interest factor is going to be 1 plus 0.10 to the 5th power. So 1 plus 0.10 is going to be 1.6105. And I'm going to divide 100,000 by that factor. And I end up with the present value is equal to 62,092.13. Okay, so which would you rather have, the 70,000 or the 62,000? I would much rather have the 70,000. So should you buy it at 10%? And the answer here is no. Okay, because you don't want less. Okay, so this illustrates a kind of an important topic when we talk about present value and interest rates. So what happened in this example? We held the future value constant. We held the time periods constant. So the only thing that really changed here was the interest rate. So one of the things we're going to say is as the rate of interest increases or goes up, the present value decreases. And that kind of makes sense because that's the opportunity cost, right? So the opportunity cost here is what else could you do at 10%, okay? So this is an important idea here. And because the present value and future value are reciprocals of each other, we can also state with clarity that, come on. All right. We can also state with clarity that as the rate of interest increases, and we would be calculating future value here, the future value increases. Okay, so those are two takeaways from this particular scenario. Let's just double check our answers here. Yes, buy it, and no, don't buy it. Okay. Hopefully that makes sense. That's the end of this particular learning objective. We're going to come back to present value again when we talk about stocks and valuation in this chapter. Thanks for your time and attention. Have a great day.